friends, hope you all are doing good and happy Easter. So in my last video we had been discussing about the hardware and software and of course we're continuing with this book, The Emperor's New Mind by Sir Roger Penrose. So what is it that gives a particular person his individual identity? Is it to some extent the very atoms that compose his body? Is his identity dependent upon the particular choice of electrons, protons, and other particles that compose those atoms? There are at least two reasons why this cannot be so. In the first place, there is a continual turnover in the material of any living person's body. This applies in particular to the cells in a person's brain. Despite the fact that no new actual brain cells are produced after birth, the vast majority of atoms in each living cell, including each brain cell, and indeed virtually the entire material of our bodies, has been replaced many times since birth. The second reason comes from quantum physics and, by a strange irony, is strictly speaking in contradiction with the first. According to quantum mechanics, and we shall see more about this in chapter 6, page 360, any two electrons must necessarily be completely identical, and the same holds for any two protons and for any two particles, whatever of any particular kind. This is not merely to say that there is no way of telling the particles apart. The statement is considerably stronger than that. If an electron in a person's brain were to be exchanged with an electron in a brick, then the state of the system would be exactly the same state as it was before, not merely indistinguishable from it. The same holds for protons and for any other kind of particles, and for whole atoms, molecules, etc. If the entire material content of a person were to be exchanged with corresponding particles in the bricks of his house, then, in a strong sense, nothing would have happened whatsoever. What distinguishes the person from his house is the pattern of how his constituents are arranged, not the individuality of the constituents themselves. There is perhaps an analog of this at an everyday level, which is independent of quantum mechanics, but made particularly manifest to me as I write this by the electronic technology which enables me to type at a word processor. If I desire to change a word, say to transform make into made, I may do this by simply replacing the K by a D, or I may choose instead to type out the whole word again. If I do the latter, is the M the same M as was there before, or I have replaced it with an identical one? What about the E? Even if I do simply replace K by D rather than retype the word, there is a moment just between the disappearance of K and appearance of D when the gap closes, and there is, or at least sometimes is, a wave of realignment down the page as the replacement of every succeeding letter, including the E, is recalculated and then recalculated as the D is inserted. Oh, the cheapness of mindless calculation in this modern age. In any case, all the letters that I see before me on the screen are mere gaps in the track of an electron beam as the whole screen is scanned 60 times each second. If I take any letter, whatever, and replace it by an identical one, is the situation same after the replacement or merely indistinguishable from it? To try to adopt the second viewpoint, that is merely indistinguishable, as being distinct from the first, that is the same, seems footling. At least it seems reasonable to call the situation the same when the letters are the same. And so it is with the quantum mechanics of identical particles. To replace one particle by an identical one is actually to have done nothing to the state at all. The situation is indeed to be regarded as the same as before. However, as we shall see in chapter 6, the distinction is actually not a trivial one in a quantum mechanical context. So, dear friends, have you ever thought about all these things that Sir Roger Penrose has described in this entire paragraph? It is quite intriguing to me though. Let's continue. The remarks above concerning the continual turnover of atoms in a person's body were made in the context of classical rather than quantum physics. The remarks were worked as thought it might be meaningful to maintain the individuality of each atom. In fact, classical physics is adequate and we do not go badly wrong at this level of description by regarding atoms as individual objects, provided that the atoms are reasonably well separated from their identical counterparts as they move about. One can consistently refer to them as maintaining their individual identities, since each atom can be in effect tracked continuously, so that one could envisage keeping a tab on each separately. From the point of view of quantum mechanics, it would only be a convenience of speech to refer to the individuality of the atoms, but it is a consistent enough description at the level just considered. Let us accept that a person's individuality has nothing to do with any individuality that one might try to assign to his material constituents. Instead, it must have to do with the configuration, in some sense, of those constituents. Let us say the configuration in a space, or in a space/time, or space-time. More about that later, but the supporters of strong AI go further than this. If the information content of such a configuration can be translated into another form from which the original can again be recovered, then so they would claim the person's individuality must remain intact. It is like the sequences of letters I have just typed and now see displayed on the screen of my word processor. If I move them off the screen, they remain coded in the form of certain tiny displacements of electric charge in some configuration, in no clear way geometrically resembling the letters I have just typed. Yes, at any time I can move them back onto the screen, and there they are, just as though no transformation had taken place. If I choose to save what I have just written, then I can transfer the information of the sequences of letters into configurations of magnetization on a disk, which I can then remove, and then by switching off the machine, I neutralize all the relevant tiny charge displacements in it. Tomorrow, I can reinsert the disk, reinstate the little charge displacements, and display the letter sequences again on the screen just as though nothing had happened. To the supporters of strong AI, it is clear that a person's individuality can be treated in just the same way. Like the sequences of letters on my display screen, so these people would claim nothing is lost of a person's individuality. Indeed, nothing would really have happened to it at all if his physical form were to be translated into something quite different, say into fields of magnetization in a block of iron. They appear even to claim that the person's conscious awareness would persist while the person's information is in this other form. On this view, a person's awareness is to be taken in effect as a piece of software, and his particular manifestation as a material human being is to be taken as the operation of this software by the hardware of his brain and body. It seems that the reason for these claims is that whatever material form the hardware takes, for example, some electronic device, one would always ask the software questions in the manner of a Turing test. And assuming that the hardware performs satisfactorily in computing the replies to these questions, those replies would be identical to those that the person would make whilst in his normal state. How are you feeling this morning? Oh, fairly well, thank you, though I have a slightly bothersome headache. You don't feel then that there is anything odd about your personality, personal identity or something? No, why do you say that? It seems rather a strange question to be asking. Then you feel yourself to be the same person that you were yesterday. Of course I do. An idea frequently discussed in this kind of context is the teleportation machine of science fiction. It is intended as a means of transportation from, say, one planet to another, but whether it actually would be such is what the discussion is all about. Instead of being physically transported by a spaceship in the normal way, the would-be traveler is scanned from head to toe, the accurate location and complete specification of every atom and every electron in his body being recorded in full detail. All this information is then beamed at the speed of light by an electromagnetic signal to the distant planet of intended destination. There, the information is collected and used as the instructions to assemble a precise duplicate of the traveler. Together with all his memories, his intentions, his hopes, and his deepest feelings. At least that is what is expected, for every detail of the state of his brain has been faithfully recorded, transmitted, and reconstructed. Assuming that the mechanism has worked, the original copy of the traveler can be safely destroyed. Of course, the question is this really a method of traveling from one place to another? Or is it merely the construction of a duplicate together with the murder of the original? Would you be prepared to use this method of travel? Assuming that the method had been shown to be completely reliable within its terms of reference, if teleportation is not traveling, then what is the difference in principle between it and just walking from one room into another? In the latter case, are not one's atoms of one moment simply providing the information for the locations of the atoms of the next moment? We have seen, after all, that there is no significance in preserving the identity of any particular atom. The question of the identity of any particular atom is not even meaningful. Does not any moving pattern of atoms simply constitute a kind of wave of information propagating from one place to another? Where is the essential difference between the propagation of waves, which describes our traveler ambling in a common place, way from one room to the other, and that which takes place in the teleportation device? Okay, friends, that's much for today. We'll continue in my next video with this interesting topic. Until then, bye bye.